All right, everybody, welcome back. Here we are, right? Week 2, day 2. First, I'm going to address a student question, specifically number 13 on the number 13, 6.5. Okay. So I'm gonna do that first. Um, so here's number 13 right here. Okay. It tells us the integral from 1 to 4. It tells us that big F prime, the derivative of big F is little f. So here's little f. So little f is big F prime. And then it's asking us for f of 4 minus f of 0. Okay. By the way, I did this entire video already, but I did not have my microphone plugged in. How embarrassing is that? So I got to do the entire video again, and that's where we are now. Take 2, everybody. Anyway, so this problem isn't that bad. Let's write down some stuff that we should know, right? First, fundamental theorem of calculus, right? So if I integrate from little a to little b, some derivative, what that's going to give me, and you know what? To keep it consistent with this problem, I'm going to change this little f to a big F, just to keep it consistent with this problem. Okay, big F prime, integral big F prime, is going to be big F at b minus big F at a. And once again, just like I did in the previous video, this is the area from x equals a to x equals b. Between the curve and x-axis. Okay. So that's that. There's the fundamental theorem. One of the parts anyway. Let's see. And this is on f prime, the area between the function f prime and the x-axis. Okay. So, sorry. It tells us some stuff in the problem. Straight away, it tells us from 1 to 4. If I integrate little f from 1 to 4, I get 3.8. They tell me that straight away. Okay. The problem is asking for big F at 4 minus big F at 0. And if you look at this difference, we can relate it to an integral, because look here, f of b minus f at a equals the integral from a to b. Okay, so this has to equal the integral from 0 to 4 of f prime. Okay, and let's think about what we know. We already know the integral from 1 to 4. Okay, so we already know this one. So what I can do is I can break up the integral from 0 to 4 in this way. Integral 0 to 1 plus the integral from 1 to 4. And again, we already know, we know the last chunk. We know this chunk is exactly 3.8. Okay? And so what we wind up with is, integral 0 to 4 equals integral 0 to 1 and then plus integral from 1 to 4, we already know is 3.8. Yep, there it is. Okay. And so what now? Yeah. Well, can we figure out what this piece is? Okay, that's the next thing. Let's look at our problem and see if we can. And look at that. Okay, this is a horizontal line segment at height 3. We can also easily see that there's 3 squares in here, so the area is going to be 3. If you think about the area of a rectangle, 3 times 1 is 3. Okay, so the integral from 0 to 1, just by doing some geometry, that area, 3 times 1 is 3. Okay, so here is what we get. We get integral 0 to 4 equals big F at 4 minus big F at 0. This is directly from the fundamental theorem of calculus. And if you look at the problem is asking for exactly this. The problem is asking for F at 4 minus F at 0. That's what the problem wants to know. So in effect, F at 4 minus F at 0, the problem is asking for the integral from 0 to 4, which is what we've been talking about. We have the results already over here. So this first bit from 0 to 1 results 3 plus, and then 3.8. We add those together, we get 6.8. And there we go. Problem is finished. Boom. There it is. Okay. 6.8, answer D. Problem done. Alright. Give me your questions if you've got them, everybody. Okay? Questions get video responses.